right, guys. Welcome to your e-learning day, and I hope you got a little more sleep than normal, and you're enjoying yourself so far. What we're going to do here is I'm just going to kind of walk through a couple of these examples, just try and refresh your memory. Please notice in the directions, you can always go back and see all of this and more specifics in the notes from Unit 5. Target 2, Parts A, B, and C is where we did this originally. All right, so each row of problems are kind of similar. So I'm going to do one problem from each row to refresh our memory. So let's start off with number 2 here. So we have the square root of 64, and we need to simplify this. Now, the issue we have with simplifying this as it is that the root of 2 and the power of 1 do not cancel each other. That's the bottom line, the main issue. The only way we're going to cancel and simplify a radical with a root is if the power underneath is the same. So essentially what we have to do is we have to rewrite 64 so that it is something to the 8th power. So can I change 64 to be something to the 2nd power? Well, hopefully we recognize that 8 times 8 or 8 squared equals 64. So then what we can do here is cancel the radical, and this would leave me with just 8. So the square root of 64 would simplify to 8. You can also just put this in your calculator, right? If you have you all have a square root button on your calculator, you could just put the square root of 64 equals 8. So number 2, pretty easy. 1 and 3 are going to be similar. All right, let's just go right down the middle here. And number 5. Now, if you try and simplify number 5 the same way we did number 2, you're going to be in trouble. Because when you put the square root of 112 in your calculator, you are going to get a decimal. And if you look at the directions up top, your answers must be expressed as exact values, no decimals. When your calculator gives you a decimal, it's a rounded number. It is not an exact value. So the question becomes, how do we simplify this exactly? And the answer is, we can't completely simplify the radical. The simplified form of this expression will still contain a radical, a factor that has a radical. But we can make it simpler than it currently is by doing some work. All right, and again, the issue is it's a root of 2, and currently we have an exponent of 1. Now, the downside about 112, which is what makes it a decimal, is there is no nice, easy way to write 112 as a number squared. Up here in 64, 64 could be 8 squared, and it all worked out nice and neat. Down here with 112, that's not the case. All right, so what we have to do is we have to try and figure out if there are factors of 112 which could be written as powers with an exponent of 2. To do that, this is where we need to bring back our factoring tree. All right, so I'm going to take 112, I'm going to break it down into factors. Well, it's even, so I know it can be 2, and it's 2 and 56. Well, 56 is even, so I know that can be 2 and 28. 28, let's just go with 4 and 7 for a little bit of change. 7 is prime, and 4 can be 2 and 2. So what I have at the end of this is 2 times 2 times 2 times 2 times 7 from our prime factors here. Let me just circle all of the prime factors, the ends of all our branches. Now what we should notice here is that those 2 factors can be written as 2 to the 2nd. These 2 can be written as 2 to the 2nd and 7th. So what we now have are 2 factors of 112, which can be written as a number squared. Notice the exponent down here is the same as the root. Once I have accomplished this prime factorization down here, what I then want to do is I want to replace the 112 with my prime factorization. 2 squared times 2 squared times 7. Now what you'll notice here is instead of having only one value with a power of 1, I now have 3 factors. 2 of them do have a power, an exponent, which will cancel my root. But currently, I can't work with this because they're all under one radical. Well, we use our multiplication property of radicals here, and we are going to split the one radical with three factors into three radicals, each with one term underneath it. So now my root of 2 cancels my power of 2. This simplifies to just 2. It does the same thing here. Now this is where we're stuck. This is a root of 2. This is a power of 1. Nothing can cancel there. So we're still just left with the square root of 7. To finish simplifying fully, we do have to multiply the factors that are outside the radical together, and that would simplify to 4 square root of 7. So the square root of 112 simplified as 4 square root of 7. All right, so let's look at one now where there are more pieces to the expression outside of the radical right from the start here. Let's just look at number 8. We'll go right down the middle here. So in 8, currently there's absolutely nothing you can do as it is written. We have 12 plus or minus square root of 27 over 9. I can't add or subtract these two terms because this is a not a radical and this is a radical. I can't divide anything by 9 because nothing is here currently divisible by all three terms. 12 and 9 are both divisible by 3, but currently the square root of 27 is not. Even though 27 is, remember, it's inside a grouping symbol. Things outside grouping symbols and things inside grouping symbols cannot have the same operation done to them to simplify. So what we actually have to do is simplify the square root of 27. So we're going to do the same exact thing we just did above in number 5, right? I'm going to break this down to 3 times 9 and 3 times 3. So the square root of 27, I can think of it as 3 squared times 3. All right, so then I'm going to replace 27 with 3 squared times 3, split that up into separate square root factors. All right, now here, the root and the exponent cancel. Oops, sorry about that. Leaving me with just 3, and then the square root of 3 comes down. All right, so what I can now do is I can replace the square root of 27 with 3 square root of 3, because I just found that over here. So let's do that down below here. So now I'm going to have 12 plus or minus 3 square root of 3 over 9. All right, so now let's look at what's outside the radical in each term, 12, 3, and 9. Is there something that all three of those values can be simplified by? Well, yes. 12 can be divided by 3, 3 can be divided by 3, and 9 can be divided by 3. Now notice I'm dividing this 3 outside of the radical, not by the 3 inside the radical. All right, so when I bring this down, that's going to be 4 plus or minus square root of 3 over 3. All right, and this right here, guys, actually is the simplified form. I know this looks a little awkward to leave it as a fraction with the plus or minus and a radical, but this is the best you can do. Unless we're going to write it as a decimal, this is the best we can do. I can't add or subtract a radical term, here square root of 3, with a non-radical term, so I can't do the addition or subtraction, and I certainly can't divide 4 by 3 and make it any simpler. And this 3, even though 3 divided by 3 would simplify, this 3 is inside the radical, and this one is not inside in the radical, so they cannot be divided by each other. So that would be your fully simplified fraction there. All right, so there you go. There's one example kind of in each row of how this works out. There's an answer key to give you the correct answers for 1, 4, and 7, and 3, 6, and 9. I want you to do the best you can. All right, try and figure it out. We will definitely be able to ask questions and go over any of these problems on Thursday, because this is going to be a specific skill we need to finish finding the zeros when we are using completing the square and isolating the variable. All right, well, enjoy your e-learning day. Hope it's a great one, and I'll see you on Thursday.